Hi, this is Susmitha, Assistant Professor, Department of Computer Science and Technology. Today we are going to discuss about error control. Error, that is, data can be corrected during transmission. For reliable communication, error must be detected and corrected. Error control is a technique of error detection and retransmission. So the types of error, the two types of error, single bit error and error. Burst error. Single bit error means only one bit of a given data unit is changed from 1 to 0 or from 0 to 1. Burst error means two or more bits in the data unit have changed from 1 to 0 or from 0 to 1. The length of the error control, the sender and receiver. Length of the burst error, the 5 bit corrupted by the error. Next one, the error detection techniques, otherwise method. So the basic idea behind any error detection scheme is to add additional information to a frame that can be used to determine if error have been introduced. So the detection method is three types: parity check, cycle redundancy check, and checksum. Error control, odd parity and even parity. So the maintain odd parity, maintain even number of ones. Example, 101 means added to the 1, even number of 1 is maintained. Odd parity, maintain odd number of ones. So the 1011, so here the 0 is maintained. Cycle redundancy check. Cycle redundancy check refers to encoding messages by adding a fixed length values. Is a popular because they are simple to implement, easy to analyze mathematically, and particularly good at detecting common error caused in transmission channel. Steps followed. So the consider the original message, that is m of x, consisting of k bit. The divisor as c of x consists of n plus 1 bits. So the original message is appending by n bits of 0 letters. So the 0 extended message as t of x. So the divide t of x and c of x, find the remainder. The division operation is performed. So here the operation, the XOR operation, the resultant appending the original message, cycle redundancy check, and sent by the sender, that is code word. So the sender and receiver, data word, generator, and code word. Here the example is given: data word divided by message of m of x, given binary bits 1001. The divisor is 1011, that is n plus 1 equal to 4. So the appending n zeros to the original message. The resultant message is t of x equal to 1001,000. So here the n equal to 3. So the divide t of x by the divisor c of x using the XOR operations. So here the Boolean algebra calculations. Next one, polynomial. A pattern of zeros and ones can be represented as a polynomial with coefficient of 0 and 1. The power of each term shows the position of the bit. The coefficient shows the value of the bit. So internet checksum is calculated value that is used to determine the integrity of data. So the sender and receiver messages, this message is divided into 16 bit words, and receiver, the message and the checksum are received. The value of the sender, the value of the checksum is word is initially set to 0, and receiver, the message is divided into 16 bit words. Sender, all words including checksums are added using 1's complement addition, whereas receiver, all words are added using 1 complement addition. The sum is complemented and because the checksum. The sum is complicated receiver. The sum is complemented and becomes the new checksum. The checksum is sent with the data, and receiver side, the value of the checksum is 0. The message is accepted, otherwise is rejected. Sender and receiver, the message is m bits, data bits are sender, generator, and n bits messenger plus checksum, and receiver side also the same thing. Let us the message transmitted 7, 11, 12, 0 and 6. So here the sender and receiver data, how they are sending it. The error control include both error detection and error correction. Whenever an error is detected, specified frames are retransmitted. It allows the receiver to inform the sender if a frame is lost or damaged during the transmission and coordinates the retransmission of those frames by the sender, including the following actions: error detection, positive acknowledgement, and negative acknowledgement. Positive acknowledgement is nothing but if the frames arrive with no error. Negative acknowledgement arrives with error. Retransmission after timeout. Frame is retransmitted after certain amount of time if no acknowledgement was received. Error control in the data link layer is based on automatic repeat request. Automatic repeat request. The categories of error control: stop and wait, automatic receive, automatic repeat request, and sliding window AQR, and go back. Again, sliding window divided into two categories: back, go back in, and selective rejection. Stop and wait AQR. ARQ. The stop and wait is a technique used to retransmit the data in case of damaged or lost frames. The technique works on principle the sender will not transmit the next frame until it receives the acknowledgement of the last transmitted frame. Thank you.